In 2007, at the Parkes Radio Telescope in New South Wales, Australia, a researcher named Duncan Lorimer was going through some pulsar survey information from a few years prior when something strange stood out amongst the rest of the data. Although, at the time, many suggested a glitch was responsible for what they found, but the first documented fast radio burst was hiding right there in the data. It has since been given the name the Lorimer burst. So, what exactly is a fast radio burst? Also known as FRBs, they are highly intense pulses of radio waves traveling at the speed of light which can only be observed for mere milliseconds or less, which is about as long as a conversation with your crush lasts. Yet their immense power carries throughout the great distances of the universe. After the famous Lorimer burst, the next FRB wouldn't be recorded until 2012 by the same Parkes Radio Telescope. A few cosmic flashes later, the Arecibo Observatory in Puerto Rico confirmed what the Australian telescope had been seeing. So, what exactly were these observatories witnessing? To this day, it's still not 100% clear what cosmic circumstances are necessary to produce such a powerful event, and as of right now, only about 100 or so have actually been recorded, so scientists really aren't working with much when it comes to FRBs. On the bright side, some developments have been made over time, such as learning to localize certain FRBs, though that's only the case for fewer than 10 of these extragalactic events. Originally, it was believed that most, if not all, FRBs came from within our own galaxy, but we were very wrong. In order to pinpoint a burst's location, it needs to be seen at a radio wavelength and an optical wavelength to compare and build on each other's data. In a second, I'm going to share some examples of FRBs that came deep from the bowels of space, but first I want to mention that just because most, if not all, FRBs we have seen haven't come from our Milky Way, it doesn't mean that they can't be produced here. The Gemini North Telescope in Hawaii picked up an FRB from a star-forming region within an arm of a spiral galaxy similar to our own. Vikram Ravi, an assistant professor of astronomy at Caltech, also commented on FRBs and galaxies who share commonalities with ours. Bars. In regards to FRB 190523, which I will mention once again in a bit, Ravi states, "This finding tells us that every galaxy, even a run-of-the-mill galaxy like our Milky Way, can generate an FRB. Okay, so let's go over 3 insanely far-out fast radio bursts. FRB 121102 was discovered by the Arecibo Observatory, and it lies 3 billion light-years away in a small galaxy. FRB 180924, observed by the Australian Square Kilometre Array Pathfinder, is about 4 billion light-years away. And lastly, FRB 190523, found by Caltech's Owens Valley Radio Observatory, with the help of the W.M. Keck Observatory, has been pinpointed to a staggering 7.9 billion light-years away. Like I said earlier, these bursts travel across massive stretches of space, so these things have got to be powerful. I mean, so powerful that a fraction of a millisecond's worth of energy output from an FRB will produce more energy than our sun will work through in an entire day. According to extremetech.com, whatever cosmic entities that emit FRBs must produce more energy in a single millisecond than our sun will produce in 80 years. So what exactly do FRBs tell us? Is there ultimately a point to collecting terabytes upon terabytes upon terabytes of data all year round for decades? Yes, I'm glad you asked though. FRBs tell us a lot about the composition of our universe and how much matter is dispersed. The high-energy radio waves carry through space and also through the matter that exists between the FRB's source and the Earth. This causes the wavelengths to reach our observatories at varying speeds, and we lay those waves out like a prism does with light. This gives astronomers an idea of how much matter exists between us and where the FRB originates from. We really don't have too much traction in the field of FRBs thus far, but if our instruments become more precise and sensitive, estimates on the higher end speculate there could be as many as 10,000 FRBs occurring each and every day. However, the more common estimate is more like 1,000 to possibly thousands, which is still a lot. As if FRBs weren't already complicated enough, some FRBs actually repeat on a regular cycle. In the case of FRB 180916, its repeating cycle of 16.35 days is just plain odd. For 4 days, the FRB bursts once or twice an hour, but then remains totally quiet for 12 days. And with FRB 121102, the entire cycle repeats every 157 days, where we get 90 days of activity and 67 days of rest. And some FRBs even repeat with a pattern, which are believed to be caused by the orbital motion of a widely dense object like an enormous star, a neutron star, or a black hole. All FRBs may repeat, but at weaker strengths, which could lead us to missing the repeat entirely and labeling them as single bursts of insane amounts of energy. A number of astronomers even believe that the intervals between repeats could be so irregular that by the time the next burst occurs, we may have since moved on from its observation or may not even still be around to witness it. Okay, so we know some basic information about what fast radio bursts are, but what exactly causes them? Well, here's the deal. Given that information gathering on FRBs is still in its infancy, there's not a whole lot of conclusive evidence. However, this doesn't mean we don't have some wild theories ranging from bizarre to creative to what are you even doing with your life?
Are you ready, kids?
The cause of FRBs could be flaring stars within our galaxy, the merging of binary white dwarf star systems, the merging of a binary neutron star system. It could be blitzars, which are basically radio shockwaves from collapsing neutron stars. It could be the active galactic nucleus of a dwarf galaxy, the collision of asteroids with neutron stars. It could be pulsars just absolutely wrecking house, or collapsing from dark matter, or traveling too close to supermassive black holes. It could be energetic supernova. It could be cosmic strings, explosive decay of axion mini-clusters, which I'm not even going to attempt to cram into this video. It could be evaporating black holes, massive objects colliding, or they could even be connected to gamma ray bursts. As you can see, nobody has a clue. A long-standing belief is that the real source of some FRBs are magnetars, which are highly magnetic newborn neutron stars which expel plasma with tons of energy. Once these extremely dense stars erupt plasma outwardly, it travels through the universe since it has the energy to sustain the journey, and then that energy collides with our instruments. The thing is, magnetars exist in highly active star-forming regions of galaxies within the supernova of primarily large stars, but FRB 190523 came from a calm area of space similar to our own, so the FRB magnetar connection is shaky at best. That being said, magnetars do give off radio waves, it's just that proving they're the culprit for FRBs is the big challenge. Plus, even if they are responsible for some FRBs, not everyone who subscribes to the magnetar theory believes that every FRB comes from a magnetar, so there's that. In general, astronomers really don't have any solid evidence to suggest that FRBs require an extremely specific environment to emerge. It kinda makes the whole explaining their origin thing kind of a pain. A more lighthearted, or terrifying, explanation for FRBs is that highly advanced alien civilizations are trying to communicate. Not necessarily with us in particular, but kind of in the same way how we've sent out some basic information in the past. Another extraterrestrial explanation is that an alien ship or transmitter is giving off crazy amounts of energy, but as far as my research has led, apparently it would need to be solar powered, water cooled, and twice the size of the Earth. Simple, really. Imagine going through all that trouble only for the entire universe to leave you on red. In the near future, we will be able to collect more data more often with certain observatories adding components to their current setups. For example, it's expected by 2021 that the Owens Valley Radio Observatory will be adding 10 new radio dishes to their Deep Synoptic Array, or DSA. Bars again. A majority of the funding for the project is coming from the National Science Foundation, so if you're interested in seeing further progress in this field specifically, make sure you show them some support, as well as Breakthrough Listen, who are looking into the connection between FRBs and potential alien civilizations, and SETI, the search for extraterrestrial—
SETI? You mean them sci-fi born-to-die telescopic Libby rows looking for aliens?
Sure, whatever, guy. If anybody is interested in hearing what SETI's thoughts are in regard to FRBs, they invited a couple of radio hosts onto their YouTube channel to talk for about an hour back in late April. I'll drop a link for you so you can see that down below in the description of this video, where all of my sources can also be found. Thank you so much for watching, and I'll see you next time.